तभी तो more busy था मैं. Yeah. Plus they're gonna start their school next week, so inshallah everything will be okay.
Okay. Inshallah, don't
So,
worry.
yeah, and one more thing, sir, the labs you have did it, I haven't received the days I missed it. So today, like end of the class, if you can send it also.
Yeah, sure. I'll send it. Don't worry. I'll send it. I think Hafiz also joined. Hello, good morning, Hafiz.
Yeah, good morning.
How are you doing, man?
I'm good.
Okay, so today all 3 people joined. I'm very happy to see you back again. Okay, guys. So I want one more thing I want to discuss, that is like I want to take training Saturday, Sunday also. It is possible for you guys?
Saturday, Sunday.
Yeah, because I have one of the corporate training from that is your American company, the Microland. So they have some Palo Alto and some cybersecurity training. So I'll be not available from 31st to 12th of August, that 11th of August. Because that's the reasons I have planned to take Friday. Today is Friday here in India. I think for you, I think Thursday night, right? The brace?
Yeah, Thursday night. Yeah.
Thursday night. Okay. So for you, I think it till the Friday, Saturday, Sunday. Also, I want to take, so that like how much I can cover the topics. Okay, those topics, all the labs I'll share you in the group, in the chart. Okay, so that you can practice. At the same time, I will send you some workbook, that is the cookbook for CCNA. Okay, so we can do all the labs. What are the labs I did? So don't do the lab which I have not taught you, so that you'll get confused.
Yeah.
Okay. So what are the workbook I will share you? Today itself I'll share you the workbook. It's one of my friends' workbook who is working for GNS3. It's very amazing book, but it is CCNP routing and switching. Okay, that all topics what they did Cisco. Okay, they have CCNP topic. They have some of the topics they have put in CCNA now. Okay, the other reason I want you to learn those topics, because the BGP is not there in CCNA. Okay, in that workbook I will share you after completing this training.
So today's BGP
training
comes in CCNP, no?
Yes, in CCNP. It's not in CCNA. So I want you people to learn, because it will really help you in your work.
Yeah.
It's very important BGP protocol. Okay, even they had an ISIS routing protocol, so which was not there in old CCNA when I learned. So now ISIS also they added, and automation they added. Okay, that all labs are available in that workbook. Okay, that workbook I will share you after completing this training. Okay, so right now I think we are live in. I think we can see live in my.
So I'll be here about 2 hours, because I have to go to pick my wife. After 2 hours, yeah.
Okay, that's the reason for you I'm not giving any break, because usually for 3 hours training I will give 15 minutes break. Okay, is it okay, guys? Lakshman and Hafiz, no problem, right? No break.
Okay, sir.
Okay, done. Because I'm not going to give the break now. Okay, so because due to the time constraint, so I don't want to give the break. Okay, so let's start the session now. Okay, this is the topic, guys, as we can see on the screen. So EHRP. So any idea about EHRP, guys? Any long form of EHRP? Enhanced Interior Gateway Routing Protocol, right? So it was the Cisco, this one, proprietary. The EHRP is your Enhanced Interior Gateway Routing Protocol. It was a Cisco. This has been designed by Cisco. We talk about this has been designed by Cisco company. But later on, it was only Cisco devices we can configure your EAGRP. So now they have made open source.
So any devices, right?
Okay, now this EAGRP you can configure non-Cisco devices. So it might be any devices like your Palo Alto, Checkpoint, Fortinet, Huawei routers, okay, HP, Dell, all routers we can able to configure the EAGRP now. Okay, let's discuss what exactly this EAGRP. So please remember, so this is the old one. This is the advanced version of IGRP is your EAGRP. Remember, guys. Okay, so EAGRP. So we shall discuss later this OSPF after the complete this topic. Maybe tomorrow I will explain OSPF, but it's very important. OSPF very important than EAGRP. Remember, guys. So right now today we deal with the only EAGRP and we'll also do the lab for that. So EAGRP is the hybrid protocol. It uses a dual algorithm. This is algorithm. It's a dual algorithm. Means diffusing update algorithm. Means it will keep on updating your database. So it maintains the topology database, rapid convergence, and reliability. It's a very reliable communication. Reliable than OSPF. Reliable than RIP also. Okay. What is the AD value for EAGRP, guys? Do you remember? 90. Okay. The AD value of EAGRP is 90 administrative distance. For the OSPF,
Which value?
administrative value.
Okay.
For EAGRP is 90. For OSPF is 110. Okay. What is the administrative value for RIP? 120. And for static, 1. Okay. So now I will ask the question. So what does this mean, guys? What does it mean? What is this administrative value? Why you are using that? Before we go for a little bit theory of the EAGRP, because understanding of this EAGRP, which will help to understand the OSPF as well. So what is the administrative value? Why we require this? Okay, as you know that the lowest value is the very reliable communication. Say example, your static routing. Okay, administrative value is 1. So directly connected is 0. Directly connected is 0. The reason why with this administrative value is, say example, in your router, I think you might know, okay, if we have the router, in one router, we can configure your EAGRP, OSPF, and even you can able to configure your RIP. Okay, even you can configure your static. All routing protocol in one router we can able to configure. For example, this is my router 1. Understood, guys? Now, I want to explain what is this administrative distance. Why they have given the standard default values for all the routing protocols. So now, when you configure this all routing protocol in single router, now you tell me, so which routing protocol it will consider as a best path? Whether the RIP, EAGRP, okay, or or OSPF or static routing.
Static routing.
Sorry, yeah.
Static routing is the best.
Okay, so what about Hafiz?
Come again?
Hafiz, the question is, this is your router, okay? This is your router. When you configure in single router, we can configure, right? Many routing protocols, we can configure RIP, EAGRP, OSPF, and static routing. If you configure this one all, so router will take which routing protocol as a best path selection.
You calculate the distance between the routers and go for the best part.
How? Which route? First, you tell me. I'm not asking how it will calculate bandwidth, delay, hop count. So I don't know.
OSPF, EAGRP, administrative distance for RIP is
This is very important. This is very important, guys. Most of the companies, they will ask before hiring you. In the single router, if you configure multiple routing protocols, so which one is the best one? So which routing protocol you will accept?
If there are many routers,
No, I'm talking only one router. Right now, I have one router. So in this router,
the static routing for me.
yes, fine. What is the reason static routing? Because of the AD value.
AD value, which is 1/2.
1. Okay.
Mhm.
Lowest value is the best. Means even you configure RIP static routing, so static will be considered as the best path. Understood? This is
Yeah, because I mean, distance is 1.
yes, because administrative distance is 1 for static routing. Correct. Suppose if you not configure the static routing now. So now you tell me which one it will select. Suppose you configure in your router. Okay, maybe you configure EIGRP. Okay, OSPF. Tavares, can you tell me
RIP,
why?
because of the ID value.
So RIP will work on hop count, right? So maximum hop count for the RIP is 15. And OSPF, what is AD value for RIP? What is the AD value for RIP? Tavares? It's a 120.
20.
One, its RIP is 120 now.
Yes, the OSPF is 110.
110, yeah.
ARP is 90.
90.
So now, suppose there is a lot of router connected. Maybe this side also you connect one more router. Okay, and this router also connected to one more router. So now this is my R1. So which path will select the best when you configure these 3 routing protocol in your network? Simple guys. So it will
EIGRP.
EIGRP.
Because of lowest value.
because of the lowest AD value. I hope you understand, right?
Mhm.
Fine. So let's move on now. So now discuss the overview of these things. Enhanced Interior Gateway Routing Protocol. That is a long form of your EIGRP. So it was Cisco proprietary. It was a Cisco proprietary routing protocol based on Interior Gateway Routing Protocol. Advanced version of IGRP is your EIGRP. It released in 1994. Unlike EIGRP, is a class full routing protocol. EIGRP supports CADR and VLSM. Okay, so your IGRP is a class full routing protocol, but EIGRP is a classless. Means it will support subnet also, because in your network, so maybe you got for network which is connected, okay, a lot of routers, switches connected, maybe a lot of department also you are running. Okay, here also you are running a lot of departments. Okay, each department you're running, you have done subnetting. That subnetting update also it will send to your neighbor router. That's the reason we'll support the CIDR value. I think CIDR means, you know, right, classless interdomain routing. VLA means variable length subnet mask. Right, variable length. Suppose if you /27, okay, what could be my subnet mask? Okay, I think 248. Right? How 248? 255, 255, 255.248. Because it is a class C, right? This is called your CIDR, classless interdomain routing. Subnet mask. This is also we'll call your VLSM. So this one also will support when you have done the subnetting. That is an advanced feature which is available in your EIGR. Probably one of the 2 most popular routing protocol used today. Okay, most of the organization they use maybe EIGRP or OSPF, but mostly OSPF because of the scalability. The scalability, maximum scalability for EIGRP is 255 hop count. Like your RIP. Okay, your RIP is maximum hop count is how much? 15, right? 16 is unreachable. Correct, Hafiz, do you remember, right?
Yep.
Right, because your EIGRP, so it will work up to 255 hop count. Okay, that is enough to where if you have more than 1,000 or 2,000 employees in the organizations, this is EIGRP can be implemented. You can deploy your EIGRP, can configure this. Compared to IGRP, EHRP broadcast fast convergence time, improve scalability prior to handle the routing loops. It has got capability to handle the routing loops, and it is a fast routing protocol compared to OSPF. Okay, compared to your EHRP as well. EHRP often use hybrid routing protocol offer the best distance vector and link state algorithm. Okay, so that algorithm we'll discuss in coming slide. Okay, now EHRP and comparison. So comparison, I don't want to explain more here. The reason, as we can see, so what is talking about is a compatible with each other. EHRP offer multi-protocol support, but EHRP doesn't. Means EHRP has got capability to communicate with RIP, OSPF, okay, and your BGP, so even your ISIS. These are routing protocol. That the reason he has talking about multi-protocol, whereas IGRP, so it is a old one, we are not using that. Okay, communication is via RTP, reliable transfer protocol. Okay, here it's a very reliable routing protocol. So best path selection via diffusing update algorithm, that is dual algorithm. Remember, guys. So this is the algorithm which will calculate the best path selection. So best path selections will be based on your metric calculations. Okay, by default, so just remember that by default your EHRP will calculate your bandwidth and delay by default. Okay, so that will be depending upon your what kind of cable you have connected for your routers. You connect serial cable or your optical fiber cable or your CAT cable. Improve convergence time, reduce the network overhead. This is one advantage. Okay, it reduces the overhead because it will calculate the best path selection. So based on the bandwidth, say example, what is the bandwidth? Say example, suppose if you want to come, Lakshman, I think I told you, right? Do you remember? So when you want to come to Kakinada to Bangalore, okay, we have many routes. You can go via Chennai, you can come to Bangalore and can go from Kakinada, Tirupati, Bangalore, and Kakinada to Chittoor and Bangalore. Okay, suppose these are 3 routes available to reach to Bangalore. So now if you talk about, okay, the highway road is available only from Kakinada to Tirupati to Bangalore, highway road, big road, like 6-track road. Okay. Right, even though it is far for you, okay, now from Chittoor to Bangalore, it is near, I guess, right? So even though it will calculate the only bandwidth, because it will take the best route, you know, right? Which is the best route? Best route is Chittoor and Bangalore, which is a short route, but it will not take that short route because the road is very small, single road. Okay, now single road means bandwidth. Bandwidth is less, right? This is the bandwidth.
Okay.
Okay, if you have the highway road where you have the 6-track, okay, even it is a long distance, okay, this will be the best path. Correct.
Yes, time saving.
Okay, that is nothing but your bandwidth and delay.
Okay.
That is your pipe size.
Okay.
Water pipe, right? Big. How much big pipe? That much of water will flow.
Smaller bandwidth take more time.
Yeah, means if it is less bandwidth, it take more time because it will delay will increase.
Yes, the traffic is increasing.
Yeah, traffic will increase. So EHRP supports rapid convergence, reduce the bandwidth usage, multi-network protocol. Means it will support IP protocol, Apple Talk routing protocol, IPX, so IGRP. So these all routing protocol it will support your EHRP. So what are the tables is formed by EHRP? So these are the tables it will form. So as you can see, it forms 3 tables: neighbor table, topology table, and routing table. Okay. When you configure the EHRP, and remember, configuration of EHRP is very easy. It's very simple to configure. Remember, guys, these 3 tables we have to remember. So neighbor table, topology table, and routing table. So if you talk about neighbor table, how does it work? First topics I want to discuss, what is your neighbor table? Neighbor discovery, how it will discover the neighbor. There are 3 conditions that must be met for neighborship establishment. First, it will send the hello or acknowledgement received. Once if you send the hello, so once if you receive the acknowledgement, So then only it will establish the connection. This is how your neighborship form in your EAGRP. It will send a hello packet, hello message, right? I know, I think you might know about who is hello. It's one of the lady name.
Sure. Martin.
Yes,
Mhm.
yes,
Yes, sir. Martin Cooper, right?
Martin Cooper. So who introduced this one? Telephone?
Graham Bell.
Graham Bell, right? Alec Graham Bell. So his girlfriend or wife, I don't know. First thing he introduced, he called to his girlfriend. Her name is Hello. Hello, Graham Bell.
Okay.
Understood, right?
Yes, sir. Yes, sir.
Okay, so her girlfriend name is Hello. Now toward the world, everybody they speak hello. Okay, let's go. Okay, so now EAS number match. What is this EAS? EAS nothing but your autonomous system number. Okay, it should be unique. So when you're configuring EAS with say example EAS with 10, and here also you should configure with EAS 10. So in EAGRP, so EAS starts from 0 to 65,535.
I don't think we're seeing the
Yeah.
we're not seeing the
Yeah, same EAS value should be matched.
no, we're not seeing it.
Sorry?
We are not seeing the board. It's your video, your pictures is showing.
No. What about Lakshman and
Yeah, I'm seeing it.
I'm okay. I can see.
yeah,
I'm also okay.
I think Hawk is checked from your side. Maybe I think something this thing issue. Because these two guys they can able to see it.
Okay, it's okay now.
Okay. See. So remember guys, when you configure the EAGRP, okay, the EAS number should be same, autonomous system number. It is a unique number. So these any numbers we can use it within this range, 0 to 65,535. This range we can use it. So now important topic here. So actually EAGRP will be neighborship will be formed, okay, and your neighbor table or your topology table or routing table will be formed based on these 4 parameters. Okay, this is 4. Okay, K values. The K values noted K1, K2, K3, K4, and K5. So K1 is bandwidth, K2 is delay, K3 is load, K4 is reliability, and K5 is your MTU. MTU means maximum transmission unit. Okay, these are by default EAGRP will calculate only these 2 values. By default, it will calculate bandwidth and delay, but this will be the optional. Okay, if you want to, we can do the load balancing. We can do your load balancing here. So how the metric calculation will be done? Okay, so metric used to EAGRP to make routing decision. Lower the metric, the better one. Okay, so bandwidth, delay, load, reliability, and MTU. Right. This is the R1. I think this is the K1, K2, K3, K4, and K5. So these are like values. By default, as I told you that EAGRP will calculate only bandwidth and delay. Okay. So analogies, think about the bandwidth as the width of the pipe. Okay, delay is the length of the pipe. Okay, what is talking about? Okay,
The thickness.
The thickness of this pipe. Okay, we'll call it as your bandwidth. Okay, and length of the pipe. Okay, length of this pipe, we'll call it as your delay. I think highway road, I can explain you, right?
Yeah.
The best example. So bandwidth is carry the capacity, delay is the end-to-end travel time. How much it take time? Okay, let's give one scenario, guys. Okay, I want to know from your side whether you followed on. Say example, this is my router. So maybe I will connect these 3 routers. Say example, okay, this is my 100 Mbps.
But you can only do 4 pieces.
Okay, and this is my 1000 Mbps.
Something traditional. Right there.
110. Okay, and this is my 10 gig. Okay, this is my R1, R2, and R3. Now, when you configure this calculation part, okay, which is the best path calculation will be done by your EHRP. How is going to calculate that?
Oh, the highest bandwidth then.
Right. So to reach to router 2, even though it is connected directly, okay, it will not take this route as the best path. This path will select it as your.
Isn't the least?
This consider as your secondary route. Correct. And this one is called your primary route.
Primary.
Okay, this is in the EHRP this one terminology. So what they will call the feasible distance. This is called the feasible distance because 1000 Mbps here.
Yes.
And here is 1 gig. To reach to router 2, okay, how it will go? It will go via this. It will not go this way. Because slow, right? Because of the slope.
Because it's slow, yeah.
Yeah. Now, who is going to decide that? Because by seeing this cable, we can able to tell, right? All you people.
Yeah.
Then who is going to decide? Router is not human being, right?
Yeah.
Then who is going to decide here now? Corporate. Who is going to decide? Because Hafiz and Lakshman, see, by seeing this cable, we can come to know this is the best route, right?
Yes, sir.
Okay, by seeing this bandwidth, we can tell this, okay, fine, this is the best route. Right. Okay, so example, this is 1 gig and this is the 10 gig. 10 gig means gigabytes.
Yes, sir.
So now, as we know, by seeing this cable, we can say, okay, this EHRP when you configured, okay, to reach to router 1 to router 2, okay, it will go via router 3 and router 1, router 3 and router 2. Right.
Yes, sir.
By seeing this, we can tell. Then how this router will come to know? Okay. Router will come to know because of your dual algorithm.
Okay.
Diffusing update algorithm. Correct. This is the algorithm which will calculate. Okay. This is it has got a very good metric. This is called a metric calculation. Understood, right? Say example, guys, Facebook. Suppose if you take the Facebook, if you keep watching the movies or any news, okay, only the relevant news will be pop up to you. Noticed?
Yes, sir.
Correct. Tabriz. Okay, because the Facebook algorithm works like this. So which are the videos you watch, okay, you like, okay, only relevant to that videos, it will pop up to you. Correct?
Yeah.
I think you might notice in your Facebook, right?
Yes.
Suppose if you are watching only comedies, okay, or just for laugh or comedy show, any comedy show, only the comedy show relevant video will pop up to you. It will come to you. Okay, this is how the Facebook algorithm comes. Same thing here also. For every router protocol, so we have the algorithms. Okay, so this diffusing update algorithm, it will calculate who is the best now, because we are the human being, we can come to know, right? Because like in our brain, it is inbuilt everything. I hope it's clear, right? This slide is quite very important, lot of information. So now how neighborship will form? Neighbor table is the most important table in EHRP, store address and interface neighbor. Okay, it will show the neighbor information and interface, from which interface I have connected to this router, my neighbor router. In the topology table, So give me the information about all the routes. The moment you configure the EIGRP here, for example, this is your EIS10, and here also you configure with EIS10 with the EIGRP. When you advertise your network, what it does means it requesting means your network. Maybe you're running 1.0 network here. So here running your 2.0 network. So it will advertise your network. Please give me your network. The moment you configure the EIGRP, which network you're running, so all the update will be received in this router. For example, this is my R1. So in its topology table, okay, in the topology table, it maintains all the tables. Say example, this is R1 and this is my R2, R3 and R4. The topology table means it's a design architect. Okay, how my R1, how many people are connected to me? Okay, this guy R2 is connected directly and R3 also connected directly to me. Again, at the same time, so R3 is connected to one more guy, that is R4. That is called your topology table. Understood? How many people are connected and which interface I can reach? Suppose example, I want to reach to R4. Okay, so I can go via R2 as well as R2, R3 as well, right? So this entry will be available here. I hope it's clear, right? So in the topology table, routing table in the autonomous system number, duals take the information and calculate the lowest cost route to each destination. As you know that lowest cost is the best, right? So if you talk about the lowest cost, the cost is nothing but a bandwidth and delay. That is example for your, especially for fiber cable, your optical fiber cable. So the cost is, I think, I think. In optical fiber cable, you have the many types, right? So you have 10 gig, 40 gig, 100 gig, and 400 gig. Right. So this thing, I think for 400 gig is one. Okay, and this is, I think, 8. So this is 8, and this is, I think, 6, and this is 4. And what is this value? This is called the cost. Lowest cost is the best, right? Because 40 gig speed. Understood, guys?
No, I did not get that one clearly.
Okay, this is the like standard speed values. This is the cost. What I mentioned here, this is the cost.
Fiber, right?
Is a fiber. If it's a fiber, optical fiber cable, also we have many types, because where some optical fiber cable. Okay, Lakshman, can you mute from your side, Lakshman? Right. See, because 400 gig. Okay, if you have a 400 gig, the cost is 1. Okay, so example, if you take the previous scenario, say this example, okay, and this is the cost. The cost is 1 here. Okay, the cost is 8. Okay, and here cost is 4. Okay, and here cost is 8. Oh, which one is the best path now? Hafiz, can you tell me? How much will come? Because this is my R1, this is R2, and this is R3, and this is my R4. Now to reach to this R2, okay, which is the best path selections? This is 1 plus 8 plus 4. How much will come? 13.
13.
Okay. Then here is direct 8, right?
Yes, sir.
Yeah.
Okay. Means directly it will reach to this side. Correct. And who is going to decide? Dual algorithm, diffusing update algorithm. This is the algorithm which will select the best path. So it will calculate this metric. This is called a metric. Okay, the lower the cost, the better the route. I hope it's clear, right? Okay, next. Next thing is your routing table. Okay, so in the routing table, the successor is the route selection as your primary route used to reach to the destination, right? The previous topology, same thing what I explained, right? Okay, with the cost is less, that will become your successor route, remember. or also we can call primary route. Fine. So now dual calculate the successor primary route and place it into the routing table and topology table. Once this shortest best route has been selected, so that will be stored in your primary route, that is your successor. Okay, and place it in the routing table and topology table. It will update. Please take this update. This is the best route, and please make an entry in your routing table and your topology table. So can have up to 6 successor, guys, not 4. It has got up to 6 successor, equal and unequal load balancing also it will manage it. 6 successor will be, you can have. Dual calculate feasible successor, that is your backup route, which will replace your topology table. That is your feasible successor, alternate route. This is for your, you can say, redundancy. For redundancy, we are using this one. Promote successor if the router goes down. Okay, if the router goes down, so this your alternate route, that is your feasible successor, will become your best route. If no feasible in the table, send the query. Send the query means it will send the hello message. Hello and acknowledgement. Multiple feasible successor of destination can be retained topology throughout all is mandatory. So we can have multiple feasible successor for destination can be retained. We can have alternate route also required, right? If one links go down, okay, one traffic is go down, so alternate route also quite very important, right?
Like plan B.
Yeah, plan B. It's like plan B. The concept here is very simple. EHRP concept terminology. EHRP router that belongs to the different AS number do not automatically share the routing table. So what is talking about? Suppose the one side you configured with the AS 10 and another you configure with AS 100. So it will not form the adjacency. It will not form your neighborship. Remember, guys, it will not form. It should be the same number. 100 means you should give the 100 here also when you configure your EHRP. The only time EHRP advertises entire routing table when it discover the neighborship, okay, and form an adjacency with it through the exchange of your hello packets. Okay, it will exchange your hello packets. Okay, once the neighborship will form, so entire your routing update will be exchanged. When this happens, neighborship advertise their entire routing table to the another. Once they form the neighborship, guys, so we can exchange, right? They exchange your neighborship. So example, like I think you know. So when new guy, you don't know about it. Okay, so once you start communication, hello man means if he acknowledge to you, then we can connect each other. Then we can start your conversation, right? Then we'll exchange your mobile numbers. The two guys, they'll exchange the mobile numbers. Then they will discuss details about it. Same thing happening. The concept here is same. After each learn is neighbor routes, only change the routing table and propagates. If any changes in the neighbor, it will automatically update. Okay, automatically it will update your neighbor table. So example is talking about how many guys. So example, I think we all are friends, right? Like Tabrez, Hafiz, and Lakshman. Suppose like, if I buy any BMW or Audi car, so I'll be very excited. I am very eager to tell you today I bought my Audi car. Okay, this is a new update, right? Okay, what I will do, so I'll update to Tabrez. So Tabrez, what I will do? Okay, so when I am not available, okay, when you people meet each other, okay, then you will discuss, right? Obviously. So Taj has buy Audi car. Maybe you meet to Hafiz or Lakshman, right? You will update, right? Or you people will not update.
We will update.
Okay. You want me to buy car or not, man?
All of us will be happy. Got a good car and
Okay. Right, obviously, get it, because this is like psychology people. If any update means, say example, I got opportunity to work in one of the top company in the world like Microsoft or IBM, the top this thing, means you get very excited and happy, and obviously will share the update to your friends and family.
Yeah.
So one of the example what I has given, say same example, right? So Mumbai, Chennai, and Bangalore. So which is the best route get, this way or this way? Who will tell this?
56 kbps.
Which is the best route? Don't
Mumbai,
read this.
Bangalore, Chennai.
Sorry.
Oh, this side 1.1.544.
Mumbai, Bangalore, Chennai.
Yeah, because you
Yeah.
know, if Mumbai guy want to reach to Chennai, okay, he will not go this way. He will go via this way. Correct?
Yeah.
Okay, now, if he want to reach to Bangalore, he will take this route only. Because of this speed. You can see, right, as you can see 100 Mbps, 100, 10 Mbps, 1.4 to 20, 56,000. What is this value? This value is called the cost. Understood? This is the cost. So terms in EHRP, guys. So just remember this when we do the lab now. Okay, feasible distance is the lowest calculated metric. Feasible distance, lowest calculated metric reach to destination. This is the route that you can find in the routing table because it considers the best path, right? So example, so if I want to reach to California from my India like city to Bangalore, okay. So for me, the best route is to California. I think is from near to West North America, I guess, right? California. See,
North America,
yeah. So for me, the best route is I cannot go from Dubai, from Bangalore to Dubai, Dubai to UK, or Dubai to California. This will be the long route to me, right? So the best route for me is whether I can go Bangalore to Singapore or Bangalore to Japan, Japan to California. This is the best route for me. Okay, that route will be considered as your best path, best route. So this will make an entry in your routing table. For this entry, we'll call it as the feasible distance, FD. So report distance by an adjacent neighbor to the specific destination. Like we can give like reportedly one more alternate also we can make an entry, and interface informations also we can put in your routing table. Route status, okay, as are identified as the being the either the passive, which means the route is stable and ready to use, that is active, which means the route is in the process being be recomputed by your dual algorithm. It will calculate, suppose is a no available in the this thing, means what is going to do, it will send the hello packet, form the adjacency. Okay, once the neighborship form, then it will try to prepare your neighbor table. In the neighbor table, it will maintain who is my neighbor, how many people are connected, how it is connected. That is nothing but your topology table. So when the topology is formed, then next thing is your routing table. The routing table, what are the routing updates available, so that all entry will make an entry in your routing table. I hope it's clear, right? If you talk about EHRP terminology and operations, okay, successor is nothing but a current route. Okay, is the route selected as your primary route to use to reach to the destination. Successor are being kept entry into the routing table. Okay, in the routing table, the successor route is the best route, we can say, best route. So example, Bangalore to Japan, Japan to California. Okay, there is no direct flight from Bangalore to California. For Bangalore to New York is there, Bangalore to Washington is there. We don't have a direct flight from Bangalore. Whether I can go to Dubai, Dubai to London, London to California. Okay, That's the reason. So shortest and best path. Okay. So this is how it's going to work, guys. Remember. Feasible distance. It work as your backup. Maybe I think in that side, so from Bangalore to Japan, Japan to California. Okay, maybe the weather condition is not good, right? A lot of rain is happening, right? So in that scenario, so alternate route will be from Bangalore to Dubai or Bangalore to London and London to California. Alternate, that we'll call it as your feasible successor. We also call it as your backup route. Okay, a multiple successor can be written in topology table. Multiple alternate will be there in your topology table. It's like the gas in topology table. So many routes. Okay, even from Bangalore to Dubai, Dubai to London, London to this one more road. Even I can go via Bangalore to London and London to California, or is Bangalore to New York. Okay, New York to California. This all route will be available in your feasible successor, which act as a backup. Okay, act as a backup. Even though it is a very far distance metric calculation, okay, it will act as your backup. Okay, main thing is your successor. Okay, if these links go down, then it will take alternate route. Plan A, B fails. Okay, then plan B, it will execute. So how EHRPs use this algorithm, reliable transfer protocol? EHRP uses the routing updates. Okay, it plays the TCP. Is called RTP, provide the reliable and unreliable services. Reliable services, the routing updates. Okay, unreliable for the hello. If is there any unhello means what is going to do? It send the hello message. Okay, this is the protocol which is used your EHRP routing protocol. Okay, for the reliable RTP. Okay, reliable transfer protocol. It use your transport layer protocol in your OSA model. That guarantee order delivery for the EHRP package to all the neighbors, because where you are using the transport layer, as you know, transport layer work based on your port numbers for the reliability. So that's the reason they have designed this algorithm for reliability. Same thing, sequence number, packet, inserting, delivering. Okay, so same thing. This he will give the acknowledgement, it will form the adjacency, then it will extend the updates. Okay, however, EHRP protocol independent does not replace the TCP/IP exchange routing information via your refined EHRP OSCF do. Okay, it is an independent. Okay, it works. It's not totally depending upon your TCP/IP because it's already using here, right? For transport layer. So transport layer is the one which is a very reliable communications. I think yesterday I was given one example to the Lakshman. Okay, so this is your house. Okay, we have the two houses here. Okay, two guy names are same. They are side by side. This is your street. Okay, if any cargo or courier guy come, okay, to whom he had to deliver any courier parcel. Both name are same. Now the house number, right? House number 101 and 102. So this is nothing but your port numbers, right? This is nothing but your port number. That's the reason. So the port number, it use your transport layer. So EHRP use this RTP, reliable transfer protocol, RTP protocol for reliable. That's the reason it's not using the TCP/IP. Understood, guys? I hope it's clear, right? Algorithm is handle the dual algorithm to compute this one. One of the dual task is to maintain their loop-free path in the every destination. It will maintain loop-free, so that once if you receive the update, suppose I think you people, I know your names, right? All you people name now. If I keep on asking your name, it make sense, guys? So unnecessary, I'm wasting my energy, and unnecessary, I'm keep on asking you your name, which I know already. If I ask Tabrez Ali, what is your name? It doesn't make sense, right? Tabrez, are you there?
Yeah.
I'm asking question.
Yes.
What was my question, man?
You asking my name. You already know my name.
Okay, why I told this example? I have to take separate training for you, man. Point-to-point communication. Okay. Why I have given the example? Because this algorithm. So what algorithm was this dual algorithm? Okay, so it will make the loop-free path to reach to the destination. Okay, so that once if you reach the destination, okay, so it will make an entry. It will select the best path selection. This algorithm, that is your successor route and feasible successor route as an alternate. That is your secondary route. Same thing. So what are the things I have discussed? Same thing has discussed. Hence, diffusing update algorithm means what is talking about? It maintains the topology table. Dual say all the path in the topology. Okay, lowest cost path is copied from the topology to the routing table. So lowest cost is the remote. So this is the best path. If you want to reach to this destination, so please make an entry in your topology table. This is the best path. In the event failure, the topology table allows the very quick convergence if another loop free path is available. If any links go down, means automatically it will update, exchange the hello message. Again, it will form your neighborship. Then immediately it will select the best path. If the loop path is not found in the topology, the route recomputed must occur. Dual query is neighbor, who in the turn may be query their neighbor and so on. Hence, it is called a diffusing update. So once you are not getting any update, means again it will close the connections. Again, it will try to initiate your neighborship.
Establish
the connection. Okay, so I think VLSM support, as I told you, that it will support the VLSM, support the variable length subnet mask, can be 30-bit subnet mask, point-to-point network. So propagate with every routers. It also support your discontiguous network. Okay, it also support your discontiguous network, means different network. This is my network. This is your HR team. Okay, this is your admin team. Okay, you have the management team. Okay, but they all belongs to the one single network, but they have been subnetted. Okay, they have been subnetted. Okay, this is we'll call it as the discontiguous network. This is subnetted. Maybe even you have the 2.0 network. Okay, even if you have the 4.0 networks, different network also it will support. That reason he has given discontiguous network also it will support. If one or more, two or more this sub network of the class, full network connected together by different class networks. So different class, maybe as I told you, this is all different class. Maybe this is the class C. Okay, even the class 2 also, 16. Okay, and /8 also, class AB in single router. In single router, when you configure different network also, it will support. That is, we call it as your VLSM. So example he has given, right? Can you see? This is my network and this is the different network. One more network here. So discontiguous network. So even if you configure the different network or same network also, it will support. So let's jump to the lab now. So I think he has given how to configure the lab. So let me configuration part. We can see this is the syntax. So as we can see, router EHRP EAS number. Okay, autonomous system number, you must give that one. So he has given topology. We'll use our topology to configure this EHRP. As we can see, the configuration is very simple here. This is my router A, B, C. Router EHRP 100. Okay, have you noticed here? So router EHRP 100 and here also 100. What is this? We'll call, this is called your autonomous system number. That is your EAS number. And here also, can you see EAS number is 100? There is an autonomous system number. It should be same. Then only they will exchange their update. Otherwise, no. Then only it will exchange their updates. Understood, guys? Fine. Now, see the configuration, the command how is given. We can see router EHRP 100 network. You have to advertise 16.0 networks. Okay, this is my internal network. That is 16 network. You have to advertise. Please take my network, and one more network is 10 network. And router B, only one network, 10 network. In router C, one network and two network, 1.0 network and 10 network. Okay, so we can see in this scenario how we can configure, guys. So we can see this is my topology, router 1, 2, 3. Router 10, as we can see, router 10 here also has given router 10. Notice, guys, this means that ES number should be same. Network, you have to authorize your network. What is my network? 200.00.16 and 200.00.8. This is my network. And here 32 and 12 means he has done the subnetting here, right? All are belongs to the different network, but it is belongs to the same subnets. So let's do this lab directly rather than this thing. He also given the verification command. Let's show IP route EHRP. So don't worry, we'll jump for the lab directly. Can I start lab now?
Yes.
Okay, so let me take this router now. So let me on this. What I will do, I'll make it duplicate this one. Copy paste, Control C, Control V. So I'll connect serial cable. Let me connect some switch. I'll make it big, guys. Once I connected the topology, okay, I'll make it big.
So we haven't been into the switch now, no?
Switching not started.
Oh, okay.
Switching not started. After completing routing, I'll start switching. Okay, so this is our topology, guys. Okay, so let's give this lab name now. So this lab name is, I'll give EHRP configuration. So let's give the IP address now, some of the IP address. Okay, I will give this one is so 192.168 1.1/24. And this is my, let's say this is 2.1. And this is 10.1.1.1. This is your /EIT.
Same subnet, no?
Different subnet. I'm using different different
Oh.
subnet. It's a different subnet. Okay, the task is here. Let me set it the task here. The first thing is assign the IP address. Okay, as per the diagram. The second one is configure DSCP to get the automatic IP address, right? And third one is configure EIGRP. A fourth one is, okay, so analyze the EIGRP packets. So this is the task, guys. Let me put it like this here. You can see, right?
Yeah.
So this is a task which I said to you now. Okay, everything is assigned now. If you want, I will assign one laptop here. This is the console one. So console, I will use this one. We can see, right? Okay, and this is my RS-232 to console. So what is this means? Usually will not access directly router, guys, right? To access the router, okay, you must have laptop, right?
Yeah.
Right. So by clicking here, we can able to access this all routers. Okay. So I think if you see here,
So we'll be doing the SSH or?
not SSH, directly you can access.
Oh, okay.
No. Right. So right now, and we can do telnet all in that. If you want, you can do SSH and telnet also. We'll configure that all, everything. So I don't want to go for each router. So from the here I want to access, or from here also we can able to access it, whichever you would feel comfortable. So there also we can configure here also. Okay, so let's configure these guys. The first thing is I'll change my, this is my R1. So interface gigabyte 0/0/0. So what is IP address? This is my 1.2,
1.1,
right?
yeah.
Okay, so I say no shut. Exit. So interface, I think serial, right? 0/1/0. Okay, so what is IP address? 10.1.1.1 255, right? So clock rate you must give, right? Can you see in the serial cable? You can see the clock symbol right there.
Yeah.
So what I'm doing is just I'm assigning the IP address, guys, for all the interfaces. Remember that. Just I'm assigning the IP address. Nothing else I'm doing it. Fine. So I say no shut. Done. So router 1 configuration is done. So let's go to my router 2 now. So this is my R2 interface gigabyte 0/. So what is the IP address for these guys? So what is the IP address? Gigabyte 0/0/, I think. IP address?
1.2, 10.1.1.
Yes, 192.168, 2.1.
Yeah.
Okay.
2.1, yeah.
So I say no shut. The moment you give no shut, the interface will come up, right?
Yeah.
Right? Can you see? The moment you have given, this interface will come up. So still these interfaces are down. You know why?
Yes.
We have to give
Because
this
we
IP address for this
configured, yeah.
interface.
Yeah, for that serial.
Yeah. So what I will do is just say I say no shut. So that interface serial 0/1/0 IP address 10.1.1.2.
10.1.1.2.
Okay. So here doesn't require your clock rate. Just no shutdown directly. You can see all interfaces are up right now. Okay.
So in the topology will be created in R1, right?
Yeah. So right now we are in R1 now. Router. Sorry, router 2. I'm sorry.
But the main topology will be created in R1, right?
Main topology.
Yeah.
No. See, what is main topology? What is main topology? So it doesn't this thing, the main topology. This is the entire thing we'll call topology, Tabriz. So what we can see.
I mean to say the R1
all,
topology table.
all will call it as your topology.
I mean to say like the R1 will be in R1 router, my topology
This
table
is
will
my
be there,
R1,
right?
right? This is my R2. Okay, right now I am R1. So what I did, just I assign this IP address. For this interface, I assign this IP address. For this interface, I have assigned this interface. Okay. For
Yes.
this interface, I have assigned this IP address. For this interface, I have assigned the IP address. So remember, okay, when you see this clock symbol, we have to give the clock rate here.
Yeah.
As simple as this.
So like in EIGRP, now you're doing the configuration. The
I have not
table will
started
be-
EHRP yet.
Oh, okay.
Okay. So just I assign the IP address now.
Okay.
Okay. So let's go to this router now, R1. So as you know that I want to configure the DHCP here so that all these end user devices, these all devices must get the automatic IP address. Let's put some design so that you people can understand, to just to avoid the confusion, guys. That's it. Okay, and this is my one network, and one more network. I'll put it in different color. This is my another network. How many other network here?
Two.
And this is my one more network, right? Right. So now you tell me how many other network? Which network is this? 192.168.1.0 network /24. And which is this one? 2.0 network. And which is this? 10.0.0.0 /8. And what is the name of this one, Paul? This is your network ID, remember. Network ID. Network ID. Right. So let's configure this. I think now we can understand, right? I have put some colors just to avoid the confusion. So 3 networks are there now. So now I'm going to configure the DHCP so that this all PCs, the end user devices, they have connected desktop and laptop and one server. So they must get automatic IP address, right? Okay. In the router also we can configure. Even the recommended is on the server, guys. Remember, in any this thing network in the companies, you can see DHCP servers. Okay, you cannot see the where you configure the DHCP or is not recommended as per Cisco. So if when you want to have the like DHCP configuration, better to put separate server for that. Okay. So let me do this. So IP DHCP pool. Okay, I will say this is my HR team. Okay, and the network. What is my network? 192.168.1.0. We should give the subnet mask. Okay, and default router IP address is 192.168.1.1. If you want to give the DNS, let's give the DNS. So IP DHCP exclude this IP address. Okay, apart from this IP address, please issue other IP address. Okay, it start from 1.2. It start from 1.2. Okay, so I think we have configured it. Let's check whether this PC will get the IP address or not. Just select the DHCP, set in the request. We are getting right 1.2.
Yes.
Okay, so same thing this side. Okay, so let me have this. Yes, we are getting the IP address. Hafiz, you are following, right?
Is there?
No, is there. Okay, so now we have got the IP address. Okay, so let's go to the R2 now. So here also we configure IP DHCP pool. Here I will give management. We can give any name, okay? A network. So 192.168.2.0, right? This side.
Yes.
Default router ID is how much? 2.1. If you want to give the DNS server, you can give the DNS server and exit. So IP DHCP exclude this IP address. That is here 2.1. That's it. So let's check whether this guy will get the IP address or not. Yes, 2.2. Right. So we are getting the IP address now. From server also we can configure, guys. I think last session, I think I told you about. So how to configure the DHCP on your server.
I haven't seen that part. I missed it.
Yeah, no problem. I'll show you that separately.
Okay.
Fine. So now every PC has got these things. As we can see, the main objective for this EAGRP configuration is, what is the main objective? Okay, right now it will not do the communication, right? If you ping from this server to server, they don't have the communication. It's fail, right? Can you see?
Yeah.
It's fail, right? The main objective for this one is so we have to make them communication using the EAGRP when you connect with the two different network. So let's do the configuration of the EAGRP. Is simple. Router EAGRP. Give the question mark. We can see, right? If you give the question mark, as I told you that it starts from 1, not 0, 1 to 65,535. Within this range, we can give any number. Okay. So I'll use this 100. I'll give just 10. Okay. I have to authorize my network. This is my R1, right? I am in R1. So which network I have to authorize? 192.168.1.0. Right. If you give the question mark, we can give the wildcard mask. Right now, not required. Wildcard mask because it is not subnetted, not required right now. Okay, one more network is 10.0.0.0. Center one, right? This one.
Yeah.
Right. And same thing if you check. So let's check do show IP route EAGRP. See, as you can see, still it is not showing anything, right?
Yeah.
Can you see? Okay, because other side also we should configure. Okay, router EAGRP. So what autonomous number I should give here? So what autonomous system number I should give here, guys? What should be my ES number here? What ES number I have given here? ES10. Correct.
Yes.
Okay. Then network. So which network I have to advertise? Who will tell me this? 192.168.2.0. That's it. This is 2.0, right? Network. Can you see? This is my 2.0. I have to authorize this one. So here 1.0 network I have to authorize with the same EAGRP autonomous number EAS10 and here also EAS10. At the same time, not only this network as well as this network here, even though it is directly connected.
So, sir, like one question.
Yeah.
Like if you're doing a real-time configuration in one of the companies, we're gonna use the autonomous like ES10, right?
Not ES10, we can
using-
give any range, right? So these
From
ES
one to the number you showed us, right?
okay, 1 to 16,000 535.
So we can give any, right?
Any number. Suppose
Oh.
if you are accessing this router, if you are giving this AS number 100, okay, you want to communicate your network to this network. So here also we should give AS
100. Same, right?
100. Same. If it is, if you give
Yeah.
101, 101, okay, it will not do the communication.
Yeah.
It will not share the updates.
Okay.
It will not form your tree table. That is your neighbor table, topology table, and routing table. It will not form because
Yeah.
AS is different. The EHR, we will think that that is a different AS number, so I cannot give the update.
Okay.
Understood, right?
Mhm.
So now we can see one more network you are missing, that is network 10.0.0.0. That's it. Can you see the moment I have given here? So adjacency is forming by dual. Can you see up?
Yes.
New adjacency has been formed. So do show IP route EHRP.
EI.
Can you see D stands for EHRP, guys? Remember. Okay, what is this 90? 90 is your AD value.
AD value. Yeah.
Remember, these parameters are quite very important to understand here. Let me explain that. Okay, so what is this?
There's the-
Yeah,
So there's the clock rate, right? 00:00.15.
this one, which one? This one.
Yeah.
No, this is not a clock. This is the metric. And this is the serial interface from where it has learned. Okay, this is the network where it has got from this router. This is the
Router
this one,
one.
right?
Yeah.
One network. So D stands for your EHRP. And 90 is
Yeah.
what?
AD value.
AD value, 90. EHRP AD value is 90, right? Do you remember?
And what about this one? So the bottom, beside serial on the left, 00:00:15.
Which one? Where?
Where the serial is, the down on your right.
Yeah, this is my network because directly connected to not show you.
No, I meant to say on your configuration side, where the serial is, and they are 00:00:15.
See, when you give this, okay, as you can see, so he has learned the network because this network, 10 network is connected directly. It will not show you this in EHRP. So D stand for your EHRP. Yeah.
Yeah, for example, you want to go on D, right? On your far right hand side, where the serial is written, the serial, beside serial 00:01:35.
Where you're talking about, I'm not able to understand.
Oh, you closed the configuration. It was on the configuration.
Where?
Yeah. Okay. 00:01:35 on your right. This right on the D, go on the right. Yeah, 00, see? Yeah. 00:01:35. Yeah, that's the one. Yeah.
So yes, see, this is the time taken to come up.
Oh, okay. Okay.
This is a time taken to come up. Okay, that is one point. It keeps changing. Suppose if I a good question. Suppose if I do once again, it keeps changing. Can you see now?
Yeah.
If I repeat once again command show IP route, so it keeps changing.
Changing. Oh, okay. Okay.
Means how long, how much time it takes to come up, right?
Okay.
Okay, now I think I can able to ping, right? So ping, so 192.168.1.1. So I have the reachability, right? 1.2. Right. So even I have the reachability for 1.3. So 1.4. So 1.5. Okay. So let's check from this router one now. Now we can see previously when you type this show IP route, so it was not showing. So when the other form, so now it has been formed the adjacency. Neighborship has been formed. If you type once again, the repeat the same command. So 2.0 network has been formed. Okay, this is the metric value, how it has been calculated. As you notice, the metric value is same, 217416. Let's check this side. a show IP route DHRP. So we can see show IP route DHRP. We can see this calculation is 416. Oh, here also, can you see same?
Yeah,
Metric calculation is same here.
yeah, with the same AD value also.
Yeah. Some command that show IP route EHRP. We can see pipe, not this. Sorry, guys. Show IP EHRP topology table. In the topology table, this is the command, guys. This is a very helpful command. So this command, that command what I have issued is this command. Show IP route EHRP topology. Topology means
Yeah.
how it has been connected. My router, how it is connected. So point, P means point. This is a passive interface. P means passive interface. So this is connected via this network. One successor. Can you see? And feasible distance is, this is a metric calculation has calculated. It is connected via serial interface.
With the AS10,
Yes.
right?
Yes. So now one more successor has given. So one network, one successor, feasible distance. This all information we can see in the topology table. So one more table we have to see, right? Show neighbor table. Who is my neighbor? Right? Can you see? 1.1.1.1 is my neighbor. This is a hold on timer, up timer, okay, SRTT and RTO sequence number. When sequence number is keep this one, how many times it has done the communication. Right?
What is RTO, sir?
Hmm?
RTO?
RTO, I think reliable transport optimization as per these things. So let me check. I forgot this one also. Let me check. I will show you what is RT. Okay, retransmission timeout. The amount of time in milliseconds EHRP will wait before retransmitting the packet from retransmission query to the neighbor.
Okay.
Okay, QCNT. The Q means
With
count.
Yeah, so with that clock, the number you were showing us, remember 00 colon
Yes.
00 is, yeah. Okay.
Can you see, right? This is the time taken. Q, right? Q means count.
Yeah.
You can see, right? Count. Because immediately we have to understand. This is a good question.
Yeah.
Right? So we can see Q means count. So RTO means retransmission timeout.
Mission timeout.
So retransmission means it will wait. Okay. The time it will wait in millisecond. The DHR will wait before retransmitting the packet from the retransmission queue to the neighbor. Okay, hold on time. I think hold on time it will take some seconds. This is the show EHRP neighbor. Okay, show EHRP profit. Okay, hello sends this much of times. Update send receive 2 times. So query send 0, reply and send receive no, acknowledge send 2 times.
Received. Yeah.
Okay, input giving high one time. So SIA query. So SIA query, let me check what is, I forgot this one. SIA, right? Reliable transport of each query. So send its neighbor. It must get reply in the response within 3 minutes. If the router doesn't receive the reply to all, it outstanding query to and put it into the route in SIA, stuck in active. Okay, within 3 minutes. So within 3 minutes, so what is talking about SIA query? Okay, when 3 minutes it will wait, because once 3 minutes, if you are not responding to me, I'll put it in stuck in in wait. Maybe I think you are active, but you are sleeping. This is the meaning of that. Okay.
Oh, okay. It's kind of standby, right? Something like that.
Yeah, standby. Okay, it's simple as this. You understood, right?
Yeah. And
Stuck in
sir,
act.
if
Yeah.
you want to see like IP EAGRP traffics,
Ah.
if there's any traffics,
The traffic we have not yet generated, right? So let's generate
no.
some traffic. Okay, let's see. What I will do, I will generate traffic from here. Command, okay, ping minus T 192.168.2.5. So let's ping continuously. Okay, at the same time, let's see this one. Continuous minus T means continuously pinging us, because this is in the packet tracer. In the real time, it will not like this. Real time ping IP address and minus T. Remember this.
Okay.
So continuously I'm pinging now. You can see continuously. So now see the traffic now.
nahi karo beta sir.
Show IP EAGRP traffic.
Do they?
See, we can see hello send receiving many times. I keep changing, right?
Yeah.
Okay. See 32. So here it was 342 and 344. It keep on increasing. Means they're exchanging, right?
Yeah.
Hello and receive, they are exchanging. Okay, what I will do, guys, I'll open this one, router this one. I will go to one of this interface, say gigabyte 0/0/0. I say no shut. Let's see what happened here. Can you see? What did you notice, guys? Who will tell this answer? For you, no break. I will take break. I will have a tea and come. Okay, you tell me what is the difference now. Now there is a no communication now because interface is down now.
Yeah.
Okay. Now why? What is the difference you can see here? Now interface is down, right? Can you see this interface is down? If you check this, see timeout, destination is timeout. Up to here we got the communication, but still is pinging. These guys continuously sending the ICMP packets to this PC. Where I ping, most probably I think I have ping from this PC to most probably I think this laptop. This guy is I think 2.5, I guess. This guy is 2.5 and this is 1.2. I have ping from this to this. Now interface is down, no communication. If you see the routing table here, so what difference we can see?
The queries too, send and receive queries.
This one?
Yeah, and a reply send we also not receiving.
Query sent, okay? Query has been sent and there's no reply.
Yeah, even reply send and
replying
receive,
0. Replying 0. Okay, input Q higher watermark is 1, drop 0. Okay, and this is the one which we want.
Yeah.
Right. So let's see up. We'll do up and see what is the difference now. What happened? Okay, I will go to this interface now. I say no shut.
Yeah, it's up now.
Okay, now we see.
Yes.
Now we are getting reply, right? The one has been changed here.
Yeah, we are getting reply.
So we are getting updates now. We are getting reply. Previously, so we are not getting the reply here. Send receive 4. Okay. So now if you type show EAGRP, show IP route. So EAGRP, let's say interface. Interface also is showing, you can see these are interfaces which is connected. EHRP configuration. If you want to check all configurations, show or run. Okay, EA show run. Let's say give 5. Okay, session. Okay, include EHRP. Let's say show run. Okay, we have configured the DHCP and IP address we assigned, and this is our EHRP. What we configure. Okay, we can configure telnet also. We'll do that telnet as well. Configurations. Telnet and SSH. Telnet, I think I configured, right? Do you remember that telnet configuration?
Yeah.
Right. So telnet also, if you want, I'll show you once again. Okay, so go to global configuration mode. So username, I will give, say I will give my name, Cisco privilege level. Privilege I will give 15. So password I will give Cisco 123. Right. So line VTY 0 to 4. Password I'll give same password. Cisco 123. Login local. That's it. Right. So I think I can able to do the telnet here. Let's break this. So I will do telnet from this side now. This time I'll not do this. I'll do telnet. So I want to access my router 192.168.1.1. Connect. So what is the username? Taj. Password Cisco 123. Right. So I can able to access my show IP route. Okay. I can access my router. Understood, guys?
Yes.
So can I access from this router? Right now, I am accessing this router to this side. So I want to access this router as well. So here also we should configure your telnet, right?
Yeah.
Okay, so username, and this time I will give Ali. Privilege I'll give 15. Say password. Password I'll give Cisco 123. Okay, so line VTY 0 to 4. Password I'll give same 123. Login local. So I want to access from my this PC now. Right now I'm in the router 1, right? Can you see? So let's configure from this side. SSH as will do now. So 192.168. This is my 2.1. Oh, SSH we have taken. So 192.168 2.1.
So beta 11 o'clock just Mommy can pick at 11.
Okay, I think this guy has, it doesn't have the IP address, right? Let's use this 1.10. Because something is there, I don't know why it's not accessing. Anyway, I think from this side I can able to access it now. So let's say exit. Okay, password exit. Okay, so telnet 192.168 2.1. Okay, Ali Cisco 123. Yes, right. I can able to access my router 2. Understood, guys? Okay, so let's give one task guys here now. So right now we are using the two routers, right? Okay, so next lab will be using the three routers now, EHRP. Okay, so what I'm going to do, same topology, I will copy and paste. Actually, I don't want to show this. You people have to design. Okay, so here what I will do, this is the task. I will add one more router here. Okay, who will do this lab? Who will accept this challenge? I'll put one laptop, one PC, and one server. Okay, so let me put it some colors just to make some coloring.
So I just have only 10 minutes, 5
Hmm?
minutes. I just have only 5 minutes.
You have only 5 minutes time. Okay. Okay, so this is the EHRP configuration, guys. This is a little bit bigger, guys. Who will do this lab? So this side, I will use, this is my 20.1.1.1/8. 20.1.1.2. That's it. And network is, let's say, network ID is 20.0.0.0. That's it. And this will be my network. So 192.168. I'll keep it. This is 3.1/24. Okay. Who will do this lab? Hafiz, are you there? Okay, I want you people to just assign the IP address. So what I will do, guys, so previously we have copied this paste. So just I want to remove that configuration, that is your EHRP. How to remove the configuration? Please see here. So go to global configuration mode. No, okay, router EHRP 10, right? Previously what we have given. You can see show IP route now. So IP route EHRP. So we cannot see any configuration now. No communication now. Same thing here also, I'll remove it. Previous configuration. Okay, no router EHRP 10. That's it. Khalas. Show IP route. There is no configuration here. Okay, no configurations. Everything is removed now. The first part we have to do, guys, we have to assign the IP address for this side, which are the interfaces. These are three routers, right? You have to assign the IP address for this interface, okay, for this interface and this interface. Then configure the DHCP here. Okay, or here also we can configure. Okay, and assign the IP address. Then if you know, we can configure your EHRP. Okay, autonomous number for this topology, guys, I'll put it 100. That is your EHRP EAS is 100. Hafiz, can you do it for me? Meanwhile, what we have to do, just assign this IP address, DHCP configurations. Then, if possible, if you do the EHRP configuration, it is highly appreciated, Hafiz or Ali, Tabriz Ali. Who will do this? Nobody is accepting my challenge, man. Hafiz, can you do it? I will give the remote access to you. Lakshman, can you do it? Lakshman, are you there?
Sir,
Can I give the remote access? Will do.
no, no, sir, no, sir.
What? Why are you getting scared? Em bayama.
భయం కాదు సార్ ఇది ఇంకా నాకు
Okay. Okay, fine. No problem. Okay, guys, I think Hafiz, are you there? Hafiz, are you there or man? Where are you, man? You know sound from your side. Hafiz, are you there?
Yeah, I'm here. I'm here.
Yeah, man. For me, just assign the IP address. Can I give access to you now? Okay, Hafiz, I will take tea break. Right. Okay, you just Hafiz and Lakshman, you please assign the IP address for router 3. Okay. Make sure that this interface should up. We can see this router 3. I think we have copied the same this thing, right? So what we can do here, no router EAGRP 10. Okay, then interface gigabyte 0/0/0, no IP address. That's it. Okay, so I think this is my configuration. So host name is, this is my R3. Okay. Hafiz, I will give the remote access to you. Please do it for me. No, not waste the time. Okay. So what we have to do, just assign the IP address for this one, configure EAGRP. Okay. Hafiz remote control. Yes, Hafiz, your turn now. Lakshman, you also just please to try to figure it out. After this lab, so we'll stop and we'll continue tomorrow. Okay.
ఓకే సార్
Okay, Hafiz, please. I have given the remote access to you.
What am I supposed to do?
Yeah.
What to do?
Okay. Assign the IP address for the interfaces for the router 3 and configure EAGRP for all the 3 routers. See, these 2 routers is already configured with the IP address. Remember this. These 2 routers already I have configured IP address and EAGRP here. EAGRP also I removed. Now you have to assign the IP address for these interfaces and configure your EIGRP for all the network and make them communicate. Okay. I have given access to you. Okay. Meanwhile, so I will take coffee and come back. Okay. When I come back means this all should be done. Fine. Okay.
They've re-established themselves as the dominant force in the English game. The proud man, David Beckett. Born in the past by Eric Cantona, David Beckett takes the iconic number 7 shirt. So he's making a bit of cracking there. Manchester United, they took all the recent wins. And he did it. David Beckett. Probably more sweetly struck. The first of 3 massive innings of Manchester United. European. The same old things. You wouldn't have to. But match it all back in the game. Time to take it. All twinkling stars in the old Trafford Galaxy. Just checking the limits of the riders. Second half. Ball playing from left to right. It's playing for their Barclays Premier League futures. They would struggle to get 10 points. Harsh credit at the outset of the season. They've won 10 games. Points that they have already accrued from the without to see them survive in any of the last 7 Premier League campaigns. It's been very good. Side against Berlin, so a lot of deflating over the second half for the Bulgarian and Manchester United. It's important that Blackpool keep up their tempo in this early stages of the second period. Keep giving their front players some ball by keeping close to them. So run away from home in particular. Wigan in their first ever Premier League picture on the opening day. 5 times on the road. After those countries. Before the new year at Sunderland. United by contrast have won their last 14 league games on this ground. The win today, they'll set a new all-time Premier League record. Campbell is going to be a difficult one for him. They have attention for Campbell. Campbell goes into minutes, he's a free kick. And we know what happens next. A brilliant play by Campbell, seizing the opportunity to try and get that village and being brought down there. So important to attack defenders when you get faced enough. Can he do it again? Closer in than he would ideally like David, but he has magic in that left foot. You've had a victory on the Trafford appearance has been weak once from a set piece. He didn't want to get beat twice on his last game. Back from the steerer over the ball again. Can he see the ball? So important. Make it look easy. Oh, he did again. The speed that was traveling. Yes. The ball made redundant. Absolutely. For the second time in the game, he finds
بالله من الشيطان الرجيم بسم الله الرحمن الرحيم In the name of Allah, the Beneficent, the Merciful.
الحمد لله رب العالمين.
Praise be to Allah, Lord of the world.
deeper this time.
Hello, guys. Yes, are you there? Lakshman, Hafiz, Ali.
Sir,
ఏం చేయలేదు మీరు ఎక్కడ పోయినా వెళ్ళిపోయినాడు హాఫీజ్ ఆర్ యు దేర్ మ్యాన్ హాఫీజ్ okay let it be man so I'll complete this one. I will do one thing, so let me stop the session because these two guys are they're not available. I think just they log in. You log in ఇక్కడ వెళ్ళిపోయినారు వీళ్ళు సరేలే చూస్తాము. we stop the session ఎందుకంటే ఇది సేవ్ చేసుకుంటాను నేను.
okay sir.
Okay, so I'll put it this EAGR. పంపిస్తాను మీది ఇది.
Okay sir.
ఏం మీది అది ప్రాబ్లం సాల్వ్ అయిపోయిందా?
సాల్వ్ అయింది సార్. నైట్ ఇన్స్టాల్ చేశాను, అయింది సార్.
అయిందా?
సిస్కో ప్యాకెట్ సార్, అయింది సార్.
ఇప్పుడు చాలా బాగా ఇప్పుడు ప్రాక్టీస్ చేయాలి మీరు.
ఓకే సార్, ఓకే సార్. ప్రాక్టీస్ కి చెప్పండి సార్, దాని మీద ప్రాక్టీస్.
కొంచెం వాయిస్ కొంచెం ఇంటర్ వస్తుంది.
ఇన్స్టాల్ చేసుకున్నాను, ల్యాబ్ చెప్పండి అంటున్నాను సార్.
ల్యాబ్ చెప్పాలి. అర్థం కావాలి.